Have you ever wondered how life survives in the coldest, darkest places on Earth? Imagine a microscopic world where temperatures plunge below freezing, and yet, some organisms thrive in this frozen chaos. These aren't just any algae, they're aromatic algae, and they've developed a superpower, the ability to resist freezing. But how do they do it without bursting like glass in the cold? These aromatic compounds don't just stop ice from forming, they actively change the way ice grows, making it less likely to damage the algae. It's like having a built-in defroster in your own cell. This is a world where evolution has created a living, breathing antifreeze system. It's not just survival. It's a sophisticated strategy that turns cold into a competitive advantage. So, next time you see a frozen lake, remember, there might be a microscopic army of aromatic algae, quietly mastering the cold, one ice crystal at a time. So, what exactly are we talking about? It's not your average algae. It's a type of marine algae that produces a special kind of protein. These proteins are so unique, they act like an antifreeze, keeping the algae from freezing in freezing ocean waters. These proteins are not just any proteins. They're specially structured to prevent ice crystals from forming inside the cells. Think of them as molecular shields, protecting the algae from the cold like a winter cloak. This kind of adaptation is rare in nature. Most organisms either freeze or find shelter. But this algae has evolved a way to thrive in conditions that would normally be lethal. What's even more fascinating is that these proteins are not just for survival. They're also being studied by scientists for their potential use in medicine and industry, as they can stabilize proteins and prevent ice damage. So, while most of us are focused on staying warm in the cold, this algae is doing something even more remarkable. It's staying alive by embracing the cold, and doing it with the help of nature's own antifreeze. You might not think about algae when you're shoveling snow, but these tiny organisms are actually fighting a battle against freezing temperatures, just like you do. Their secret weapon? An antifreeze protein that prevents ice from forming inside their cells, keeping them alive when most organisms would die. And here's the kicker. These proteins could inspire new antifreeze technologies for medicine, food preservation, or even space travel. So next time you're out in the cold, remember that somewhere in the water, algae are quietly mastering the art of freezing without dying. Imagine 2.5 billion years ago. Earth was a boiling soup of chemicals, and life was just beginning to take shape. Among the earliest forms, algae thrived in the primordial seas, slowly evolving to survive the harshest conditions. As ice ages came and went, these ancient algae faced freezing temperatures, and somehow they developed a way to survive by producing antifreeze-like compounds that prevented their cells from bursting. Fast forward to the 1960s, and scientists first stumbled upon these natural antifreeze proteins in algae, sparking a wave of research into how life adapts to extreme climates. Today, these algae are more than just survivors. They're a model for bioengineering, helping us understand how life persists in the harshest environments on Earth and beyond. From ancient oceans to modern labs, the story of aromatic algae is one of resilience, adaptation, and the quiet power of nature to outsmart the elements. So imagine you're a tiny algae in a really cold lake. You need to stay alive, right? Well, this algae has a special trick up its sleeve, like a superhero's secret power. It makes a special kind of chemical that acts like a kind of antifreeze. Not like the stuff you put in your car, but something that helps it stay liquid even when it's super cold. But here's the cool part. The algae isn't just making this stuff to stay alive. It's also using it to stay safe from predators and even to grow better in cold weather. So this algae is like a clever survivor. It uses special chemical to protect itself, grow, and even trick its enemies. All in a really cold world. In short, this algae is like a tiny smart inventor, making a special chemical to survive in the coldest places on Earth. So let's start at the very beginning, when this algae first encounters the cold. It's not just a temperature drop, it's a survival challenge. the water around it is freezing, and if it doesn't adapt, it'll be a casualty of winter. But this algae isn't just passively waiting for the cold to hit. It's prepared. Inside its cell, there are tiny molecules that act like a first line of defense. These are the antifreeze proteins, quietly ready to do their job. How do these proteins know exactly when to act? It's not random. They respond to temperature changes with incredible precision, almost like a built-in thermometer. The colder it gets, the more they work. And here's the clever part. They don't just stop ice from forming. They also slow down the growth of ice that has already started, giving the algae a fighting chance to survive in the harshest conditions. This is how it all starts. The setup is simple, but the science is profound. The algae has a built-in, molecular-level strategy to survive the cold, and we're just beginning to understand it. When the algae sense the cold, they start producing a special kind of protein that acts like a molecular shield. These proteins are structured in a way that prevents ice crystals from forming inside the cell, stopping the freezing process. This binding isn't just random. It's highly specific, allowing the algae to fine-tune their antifreeze response to the exact temperature they're facing. In this way, the algae don't just resist freezing, they control when and how it happens, giving them a powerful survival advantage. This is the heart of their adaptation, a molecular-level strategy that allows them to thrive where others would perish. Now here's the clever twist. These algae don't just passively absorb antifreeze. They actively engineer their own version of it using special proteins inside their cells. These proteins are like tiny molecular architects, precisely shaping the ice crystals to prevent them from growing too large or causing damage. By doing this, they avoid the need to store large amounts of antifreeze, which would be energy-intensive and inefficient. This kind of adaptability is why these algae can thrive where others can paint. They're not just surviving, they're evolving in real time. Underneath the surface, these algae are performing a biochemical symphony. Their cells are packed with proteins that act like molecular icebergs, preventing freeze damage in freezing waters. These antifreeze proteins are not just any proteins. They're engineered to bind to ice crystals, stopping them from growing and rupturing the cell membranes. What's fascinating is that these proteins are made from a mix of amino acids, some of which are rare in other organisms, giving the algae a unique biochemical edge. The algae even tweak their protein production based on temperature, ramping up antifreeze activity when conditions get colder, like turning on a biological thermostat. This isn't just survival. It's a kind of evolutionary sophistication, where the algae are literally rewriting the rules of cellular resilience. Imagine a world where the cold isn't just cold, it's a villain with a grudge. Aromatic algae have evolved to fight back, like a superhero with a secret weapon. It's like having a personal heater in your cell membrane, keeping things warm enough to keep the cold at bay, even when the outside world is freezing. In a way, their antifreeze is like a cozy blanket that doesn't just keep them warm. It keeps them alive, even when the world is frozen solid. So, in the grand story of life on Earth, these algae are the underdogs with the most powerful superpower: survival in the face of the coldest extremes. Before you go, if you enjoyed this, please give it a like, and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.